This is the C2 2- Lewis structure, the dicarbide ion. For the dicarbide ion, carbon on group 4 or 14 on the periodic table, 4 valence electrons. We have 2 of them, we'll multiply by 2, plus we have 2 additional valence electrons that we need to add for a total of 10 valence electrons for the C2 2- Lewis structure. We'll put our 2 carbons here next to each other, and then we'll put 2 valence electrons between them to form a chemical bond. We've used 2 valence electrons, and then around the outside 4, 6, 8, and 10. We've used all 10 valence electrons. We can see that we have an octet on this carbon, but this carbon right here only has 4 valence electrons. So we're going to have to share some valence electrons in order to achieve an octet on both carbon atoms. Let's take these 2 valence electrons here and share them with the carbon to form a double bond. We're still using 10 valence electrons, and we still have an octet on this carbon. This carbon only has 6, but we're getting closer. Let's take this pair here and move it to the center to form a triple bond. Again, we're still only using 10 valence electrons, but we have 8 valence electrons around this carbon, and now this carbon also has an octet, so its outer shell is full. So we've used all 10 valence electrons for the C2 2- Lewis structure. Each of the atoms has an octet, so this is the Lewis structure for C2 2-. One last thing, we do need to put brackets around this molecule here to show that it's an ion. Since electrons tend to spread out in an atom and be as far away as possible from each other as they can, why don't we move these 2 here and these here to the end just to make it a little more symmetrical and have these electron pairs further apart. So that's the Lewis structure for C2 2-. This is Dr. B, and thanks for watching.